Hello class, this is a video tutorial on the chain rule. Before we go on, consider how the composition of functions work. So f of g of x, we've learned that is just putting g inside the function of f. So this can be seen as embedding a function inside of another function. So here are three examples I've written up. So let f be x cubed. Let g be x squared plus 1. F of g of x means to take this function and put it inside here. So notice how this is still x cubed, but inside of that function now is g of x. Likewise with this, square root x and 3 minus x cubed. Notice how p of q of x, we still have that square root of x, but where x once was, we have embedded the function of q inside of it. Even this one here, we have the function sine t squared and 2t plus 1. If we embed or put b inside of a, we get this. So notice how you still have sine t squared. So this is just t squared, but inside of t is another function. In order for us to differentiate composite functions, we use what is known as the chain rule. So for this, if you have a function y equals f of g of x, the derivative of this is y prime is equal to f prime of x. So we differentiate the outer function as if it was on its own. Notice how the g is still the same, but then we just multiply by the derivative of the inside function. Okay, so let's go straight into some examples for this so we can see this in action. First, break down what you see. We have x cubed, and inside of that is 3x. So y prime, its derivative, we differentiate the outer function x cubed, so x cubed. The derivative of this is just 3x squared. So if we were to apply that to this, it will just become 3x squared, but the inner function, nothing will change just yet. 3x minus 1. So we have differentiated the outermost function, but then to this we need to multiply by the derivative of the inside function. Well, the inside function here is 3x minus 1. The derivative of 3x minus 1 is just 3. So this becomes 3 times 3. So summarizing this, we get y prime equals 9 bracket 3x minus 1 all squared. So this is the derivative of the original function. So remember, it's the derivative of the outside function. I'll show you again. The derivative of the outside function, keeping the inner function the same. And then we multiply by the derivative of the inside function. So let's do this one again, just to emphasize further. Let's break this question down again. We have x to the power of 4. The derivative of this, so since we're now going to differentiate, the derivative of x to the power of 4 is 4x cubed. So we're going to differentiate the outer function first. So 4x cubed, leaving the inside function exactly as it is. 5 minus 2x squared. To this now we multiply by the derivative of the inside function. So to this, the derivative of all of this, so 5 minus 2x squared, the derivative of this is just going to be negative 4x. So we need to multiply this by negative 4x, bringing these two together. 4 times negative 4 gives us negative 16x times 5 minus 2x squared to the power of 3. So I hope you're seeing it's the outer function, the derivative, times the derivative of the inner function. Okay, so let's make this slightly more complex. So here we go. Hope you can see the two functions here, x squared. So the derivative of that, y prime, is just going to be 2x, and the inside function, nothing will happen just yet. 7x squared minus 2x times the derivative of the inside function. Well, there are two terms now. The derivative of this is going to be 14x, and the derivative of negative 2x is negative 2. But notice how, because we are multiplying by the entirety of the inner function, it should remain in a bracket like so. And for this, we leave this now as 2 times 7x squared minus 2x times 14x minus 2. And just to exercise our algebraic skills, notice how in this one we can factor out a 2. So this is going to be times 2, let's use a different color to show, times 2 bracket 7x minus 1. And in this one here, we can factor out an x. So it'll be 2 times x outside of 7x minus 2. So factoring this one, we get this. And bringing all of this together, we get 2x times 2. So, you know what? I'll just move this down. 2x times 2, we get 4x times 7x minus 2, 7x minus 1. So that is the final answer to this, keeping everything in as simple factored form. Okay, so I'll pause and let you try these next three yourselves. So here we go. Once again, hope you can recognize the outer function. The outer function is 5x cubed. To differentiate this, you should see that it's 15x squared. So differentiating first the outer function, 15x squared, and leaving everything inside that function intact. And to this, we are multiplying by the inside of the function. The derivative of this inside will be 4 minus 2x. And I hope you can see this expression can be factored to become 2 outside of 2 minus x. Whereas this one can't really be factored because it is x squared. So it'll be 15 times 2. This will give us 30 outside of 2 minus x, bracket 4x minus x squared, all squared. So that is our derivative of this function. So these are getting just slightly more difficult, but it's still the same application of this rule. Okay, let's keep going with these last two examples. Once again, I hope you can recognize the two functions. We have negative 4x to the power of 4, 4x to the power of 4. That derivative, we bring this power and multiply it to the front. Negative 16 x to the power of 3, keeping everything on the inside the same. And now we multiply by the inside function. The derivative of the inside function is going to be 2x minus 3. And that one cannot be factored, so we just leave it as y prime equals negative 16 2x minus 3 x squared minus 3x to the power of 3. Okay, so let's move on here. And one more time. Hope you can again see the two functions. We have 6x to the power of 5. So multiplying the power to the coefficient, 30 x to the power of 4, leaving the inside function the same. And then we multiply by the derivative of the inside function. This gives us negative 6x. And this will give us y prime equals 30 times negative 6 is negative 180x. 2 minus 3x squared to the power of 4. Okay, so I hope that gave you an insight into applying the chain rule. Hope to see you in the next video where we tackle some more challenging problems. Hope to see you then, and best of luck.